Okay, so we're going to learn about a new way to measure angles. You should be familiar with degrees. There are 365 degrees in a full circle. We're going to learn about radians. So if you look down here, you'll notice in this circle that we started with a radius. And then if we take that radius and stretch it along the outside of the circle, and we draw in the angle, that terminal side that would be required to reach the end of that radius, then the angle formed in the middle has a measure of 1 radian. So if we watch this again, we can see that the first step is going to be to draw in the radius. Then we say, okay, that's how long our radius is. We draw that circle. And we're going to measure that distance along the outside of this circle. And then if we connect that, that angle right there has a measure of 1 radian. And it turns out that if you measure all the way around here, that we have 3.14 or pi radians in half of a circle. And if we measure all the way around, if half of it is 1 pi, then the full circle is 2 pi, approximately 6.28 radians in a full circle. So a lot of what we measure in trigonometry uses radian measure rather than degree measure, so we want to be able to be sure that we can go back and forth. As we noticed back here on the front page, that 1/2 of a circle was pi radians, so that's going to be our conversion factor. When we convert degrees to radians or radians to degrees, we're going to use the fact that we know that there are pi radians in 180 degrees. This will circle back around. We can just see it again really quick. 1, 2, 3, and then pi radians for half this circle, which we know is 180 degrees. So if I want to convert 270 degrees, we're going to do this just like we do any other conversion, knowing that 180 degrees coincides with pi radians. If we start with 270 degrees, we want to get rid of the degrees and we want to turn that into radians. So that means that since my degrees are in the numerator, we need to put degrees in the denominator and radians in the numerator so that I can cancel those out. Degrees divided by degrees is 1. And I know that I need pi radians and 180 degrees. So my degrees cancel out. And now I need to simplify this. I don't want 270 pi over 180, but 270 and 180 are both divisible by 10, right? So we can simplify that and say that 270 over 180 is the same as 27 over 18. And now you might notice that 27 and 18 are both divisible by 9. So 27 divided by 9 is 3, and 18 divided by 9 is 2. We multiply straight across, we get 3 pi over 2 radians. So we can see that this makes sense. 270 degrees is at the bottom of a circle down here. So if this whole top half of a circle is pi radians, then this would be 1/2 pi radians, or pi over 2. We could write 1/2. This would be 2 pi over 2, 2 halves of radian, and this would be 3 pi over 2. 1/2, 2 halves, 3 halves, and then back around to 4 halves, or 2 pi. So it makes sense that 3 pi over 2 would be the same as 270 degrees. So maybe something smaller. If we're starting out with 30 degrees, again, I want to convert into radians, so I'm going to put degrees in the denominator so that I can cancel those out, and I'm going to have radians in the top. I have pi radians for 180 degrees. Now my degrees cancel out. And now, again, 30 and 180 are both divisible by 10, so we'll divide both those by 10. And we get 3 over 18. 3 and 18 are both divisible by 3. So 3 divided by 3 is 1, 18 divided by 3 is 6, and what we get is 1 pi over 6, or just pi over 6 radians. So what if we want to go the other direction? We say I have radians, and I want degrees. Now I know that my radians need to be in the denominator so that I can cancel those out, and my degrees need to be in the numerator so that they stay. I still have 180 degrees for pi radians. And as we start canceling out things that divide to 1, pi divided by pi is 1, radians divided by radians is 1. And then I have 5 times 180 divided by 3. I don't know what that is off the top of my head, but I know that 3 goes into 180 60 times. 3 goes into 18 6 times, and then the 10. And 5 times 6 is 30, and add the 0. And this is 300 degrees. So if we do that for pi over 4, radians is in the numerator. That means I need radians in the denominator, degrees in the numerator, 180 degrees, pi radians. When I start canceling out what divides to 1, radians divided by radians is 1, pi divided by pi is 1, and then I have 180 over 4. Now, you know that 180 divided by 2 is 90, so divided by 4 would be 45. You also have a calculator. I'm just not holding one in my hand. So there you go. Now we know how to convert radians into degrees and degrees into radians. There's a practice worksheet and quizzes for the end of the week. Good luck, guys.